All right, hello. I'm back again with part two of function operations. Now that we've done addition, subtraction, multiplication, and division, we're going to talk about function compositions. So, as I mentioned in the last video, we can think of function as like a function machine. A composition of functions is when we have more than one function that we want to work together. So you can think of it as like having a couple function machines set up back to back like this. Perhaps we have a function here, maybe it's x plus 3. And over here next to it we have another function, we'll call it g of x, and maybe this is a quadratic, a simple quadratic x squared. A composition of functions means we're going to choose some input, perhaps it's 3, and we put it into our first function and we get some output. In this case we would get 6. But then we take that output and we plug it into the next function machine and get a second output. In this case, 6 squared would give us 36. That, in essence, is a function composition, where we're combining two together. Here's another display kind of showing the same idea, where you have some input for f of x, and after it goes through f of x, we get an output, and we take that output, put it into a new function g, and then g produces another output. Composition of functions. So, we should talk about notation here. This one looks a little bit more different than in our last video. This one will take a little more getting used to. If I have a composition of a function g with a function f, the way we would write that is with a g little circle f in parentheses and an x. And the way you would read this is that it's g of f of x. G of f of x. Here it is again here. And literally what that means is we're putting a function f of x inside g of x. You could rewrite this as g of f of x. The idea is that we're going to evaluate f of x first, take that answer, and then use f of x as the input into g. Now, all that may have sounded a little confusing, but when you look at some actual examples, it's not so bad. Here we have a couple functions. F of x equals x squared plus 2. Our second function, g of x, is x minus 4. We're going to find f of g of negative 3. Now, there are two different ways we can approach this. And so on the left here I have what I'm calling method 1, which is that f of g of negative 3 can be thought of as f of g of negative 3. And in this first method, we're going to start with this piece. We're just going to figure out g of negative 3. And so I'm going to go over here on the side, and I'm going to figure out g of negative 3. Well, g of x is x minus 4, so g of negative 3 would be negative 3 minus 4, which is negative 7. Coming back over here to our original problem, I just figured out that g of negative 3 is negative 7. So now I'm going to replace g of negative 3 with just a negative 7. And now I'm going to figure out, well, what's f of negative 7? Looking back at f of x, f of negative 7 would be x squared, or negative 7 squared, plus 2. And we would get 49 plus 2, or 51. So f of g of negative 3 is equal to 51. The other way you could approach this, we'll call this method 2, would be to actually combine the two functions first, and then plug in negative 3. So if f of g of x can be thought of as f of g of x, like so, we're plugging g of x into f, we can actually figure that out algebraically. I'm going to take g of x, which is x minus 4, and I'm literally going to plug g of x into x in f of x, which would look like this. Instead of x squared plus 2, I'm going to plug g of x in for x. This would be x minus 4 squared plus 2. Notice I've taken g of x, which was x minus 4, and I plugged it into the f of x function where the x was. Now I can evaluate this piece. I'm going to do x minus 4 squared, which of course is x minus 4 times x minus 4. And we get x squared minus 8x plus 16 to give us this new function, x squared minus 8x plus 18. Now, the original problem asks us to find f of g of negative 3. Now that I've combined those two functions, I'm going to plug negative 3 in for x. We would get negative 3 squared minus 8 times negative 3 plus 18. That would be 9 plus 24 plus 18. And notice that we get the same answer here. 9 plus 24 is 33 plus 18, and we get 51, which is the same solution that we got before. So this, in essence, is function composition, where we can take one function and plug it into the other. Either of these methods works. You can either evaluate g of x first to get negative 7 and then plug that into f, or you can do the function composition with the two functions first algebraically, then plug in your value, in this case negative 3, and you'll end up with the same answer. We can see how a function composition could work in a story problem if we look at this question here. Your teacher offers to give the whole class a bonus if everyone passes the next test. She will add 10 points to the test and also increase the test score by 9%. That's pretty nice. If x is your test score, write a function b of x that represents your test score after the 10-point bonus. Well, if x is my test score, b of x would equal my test score plus the 10-point bonus. Part B says if x is your test score, write a function p of x that represents your score after a 9% increase. Well, if x is my test score and we increase it by 9%, we would take p of x would equal my test score times, we don't want to multiply by just 0.09. If I multiply by 0.09, I would be finding 9% of my score. But I want to add that to my existing score. So one way to do that would be to take my test score and multiply it by 1.09. Essentially, we're multiplying my test score by 1 plus 9% more. So p of x represents my test score after a 9% increase. Part C says let's do some function compositions. Find b of p of x, and then switch it. Find p of b of x. Well, b of p of x means I'm going to plug p of x inside the original function p of x. So I'm going to take 1.09x, and I'm going to plug it into x here. And so b of p of x would equal 1.09x plus 10. If I do this the opposite way, p of b of x, it means I'm going to take b of x and I'm going to plug it in for x here. So p of b of x would equal 1.09, and instead of x, we plug in the x plus 10. By looking at these two functions, we can decide what these functions tell us about the bonus. Is it better to increase your score by 9% first and then add 10? Or is it better to add 10 and then increase your score by 9%? Well, when you distribute the 1.09, you get 1.09x plus, if you do 1.09 times 10, you get 10.9. This makes it easy to compare the two results. Here, it's 1.09x plus 10. Here, it's 1.09x plus 10.9. We can now see that if it's done in this order, if we add 10 first and then increase our score by 9%, we will actually end up with a better score overall. So this has been your video on function compositions. The second half of the homework page has several problems with function compositions. Try those practice problems. I've also posted an answer key, so when you're done, grab that answer key and check all of your work. Until next time, everybody, enjoy your time at home, and I'll be posting more videos as the week goes along for Unit 6.